feedback from some of our customers and trying to determine and figure out how to, on an Intel platform, put the display, whether it's an HDMI 1.4 TV or a local flat panel display, how do we get that display into 3D, into its 3D mode? Okay, so we came up with a new API, a new display API that's available also in the Media SDK. It's delivered with, distributed with the Media SDK. And that API now allows for applications to go ahead and put the display into 3D mode before sending the content for a presentation to the screen. So as Andy talked about earlier, HDMI 1.4 TVs are definitely supported today, and we're also enabling for Intel for our EDP solution as well with some of our panel vendor partners to have panels available, 3D panels available for laptops and all-in-one systems as well. Okay. I want to step back, take a look at architecture for a minute. So a little bit of hardware architecture discussion here. So we put some things in place for software. Got APIs targeted for MVC, transcode, encode, decode. We got APIs targeted to allow apps to go ahead and put a display attached to an Intel platform into 3D. Now let's talk a little bit about the hardware enabling that has to happen for our Intel platform. So here we have the scenario of active shutter glasses. As Andy talked about earlier, there's still active shutter based solutions out there. So we wanted to make sure we cover an active shutter platform. Although in the future, the auto stereo is coming. Right? That's our holy grail. That's our that's kind of the end goal, is to rid ourselves of having to wear glasses. So, looking at this diagram here, in a typical system, S3D or Intel S3D EDP solution, we have enabled panel. That panel has specific firmware. It has LED drivers for the panel itself. And so, after content's decoded and ready to present out to the display, the controller sets up the panel for the 3D content. Next comes in the Intel solution, and other solutions you see out in the market as well. But specifically for Intel, we have what we call an emitter control signal. That emitter control signal sitting within the panel, TCON firmware, and that's the single most important signal to make sure that the glasses are synchronized properly. So that signal is sent from the TCON down to the emitter, preparing to send it out to the active shutter glasses to switch on the left or the right, depending on what frame is coming up next. And then finally, the data is transmitted out. You get clear viewing experience. Left and right signals are coming out to the glasses just fine, and ultimately you have your viewing experience. Okay. So now moving on to the auto stereo. This slide talks a little bit about some of the technologies around auto stereo. Some of the things that we see, some of the technology we see out there in the marketplace now, parallax barrier, which is a barrier put on top of the screen to present the left and the right eye viewing angles. So it's more of it's a barrier that refracts the light that's associated with each eye. And this barrier can be switchable. So, moving from a 3D viewing environment back to a 2D desktop, so that barrier can be turned off. One of the drawbacks to having any barrier is the fact that it could reduce the brightness of the actual content. So some of the solutions to that is to kind of boost up the backlight brightness on the content as well. Next, lenticular. So that's a cylindrical lenses. Another associated barrier, but this barrier is a barrier of lenses, and those lenses are set up such that it refracts the light to your left and the right eye. Again, in this scenario, you get full brightness because you're actually refracting the content to each eye. There's not a real barrier per se. But also there's, at 60 hertz, you're going to see a reduced resolution, a reduced horizontal resolution. So. And then ultimately, what's good for a single viewer type of scenario is head tracking. So that's adding a camera to the lenticular scenario. And that camera, based on this algorithm, tracks the user's head movement, and then refracts the light and the content based on where that user is associated with the panel. So lastly, I want to talk a little bit about, also going back to the hardware scenario. I want to talk a little bit about how we have the setup for displays EDP connected to the platform, to an Intel architecture type platform, Intel 4. For notebooks, the EDP connection is sitting off of the processor itself. And then in the desktop scenario, you have the EDP sitting off of the PCH. And based on the two scenarios, one would have to set up the platform to make sure that our video BIOS, our driver, some of the software components knows what platform you're on, desktop, mobile, knows where the display is sitting, what port the display is sitting off of, and then ultimately giving that great 3D experience.